Hello, in this lesson we're going to speak about vectors in 3 dimensions. So in order to explain what a 3-dimensional vector is, let's first draw our 3 axes. So over here we can see our 3 axes. Now these 2 axes are perpendicular to one another, and this is the axes that we know as if we're looking at our screen like it's a page, and these are the axes that go along the page that represent our 2-dimensional page. This axis over here represents the 3rd dimension, and we can imagine it as coming out of our screen towards us. This axis is also perpendicular to these other 2 axes. Now the way that we're going to label this is that this is our x-axis, okay, the axis that is pointing towards us out of the page. This is the y-axis. Sorry, I didn't mean to draw that hat. And that this axis up here is our z-axis. So now let's imagine that I want to describe some kind of point in space. So when we're dealing with a 3-dimensional vector, I write it like so. So I'm going to have my x value here, my y value here, and my z value over here. Okay, so let's say I want to describe the point 1, 2, 3. So now let's see how I draw this point over here. So what we can do is we can imagine that on our x-axis we have a scale. We have a scale like so. And I'm just reminding you that this is our x value, this is our y value, and this is our z value. So in x, I'm going to go along 1. So let's imagine that over here is my value 1. So now what I'm going to do is I'm going to draw a dotted line along which my point can be. And notice that I have a 90-degree angle between my x-axis and the dotted line. Okay, or in other words, my dotted line is parallel to my y-axis. So my x-coordinate is going to be somewhere along here. Then let's look at our y-axis. Now our y-axis is also going to have scales, and we can see that our y value is 2. So let's say that this point over here is 2. So what I'm going to do is I'm going to draw a dotted line and see where it intercepts over here. And again, there's a 90-degree angle over here, and this dotted line that I just drew now for the y value is parallel to my x-axis. So that means that along the xy plane, my point is going to be here. And now we go into our 3rd dimension. This is the 3, which means that we're going up. So we go into our z-axis, and again, we have a scale. So we can see that our z value here is 3, so let's say that that is this point over here. So now what I'm going to do is I'm going to draw a point. Now notice that this also has a 90-degree angle between the dotted line and our z-axis. And the reason I'm drawing this a little bit slanted is because you have to imagine that this is in a diagonal coming towards us. So it's at 45 degrees to my x-axis and at 45 degrees to my y-axis, and it's coming straight out towards us. Okay, so then we can see that if we draw this, our point in 3D space is going to be here. Okay, so this is our point P. And, of course, this dotted line over here is at 90 degrees to the xy plane. Okay, so now we have our point P, but how do we define this vector when we're in 3D space? So the way we did it when we were working in 2D space, just on the xy plane, is that we would draw a line from the origin up until our point. So we're going to do the exact same thing here in 3 dimensions, and we're going to start from our origin and point it towards our point P, and it's an arrow because it's a vector. It has a direction. Now this arrow, as we said, is a vector. So let's call this vector, let's give it a name, let's call it A. And remember that when we're defining vectors, we have to put an arrow on top of its name to denote that it's a vector. And so then, what will we call this vector? So our vector A is given by just the coordinates 1, 2, 3. Okay, so just like in 2D, we draw an arrow from the origin until our point in space, and we then can give a name to that vector. Now, the components of this vector, as we can see, we have 1, 2, 3. So these are components. So this component is our vector A's x component. This is our vector A's y component. And this is our vector A's z component. And this is, of course, exactly how we denoted the components of our vectors in 2 dimensions. The only difference is that now we have a third coordinate, our AZ. Let's do another little practice in order to understand. So here we have our 3-dimensional axes again, our x, our y, and our z. And here we have some kind of vector, and let's call this our b vector. Now our b vector is comprised of the x component, its y component, and its z component. Okay, so let's imagine that I don't know what this point is, and this point is obviously defined by these components. So that means I don't know what these components are. So how can I find out from this sketch what my components are?